Questions, comments, concerns? Would anyone like me to do? Why are we playing Tetris? Jacob, you don't even have your stuff out. Give me your phone. No, that's your nope. I ask you every day. Now it's mine. Okay. You don't even have your. If you had your stuff out, like I asked you to get out a couple minutes ago, I would have taken your phone, but you didn't. You didn't even have that ready. Is there any questions from what I assigned yesterday that anyone would like me to go over? Yes. Number 9. So here is number 9. Negative 84 equals 2 bracket n minus 3 plus 10 bracket n, negative 3 minus 5n. So first step on a question like this is to distribute, because we've got multiple things going on being multiplied here. We don't have just one little thing that we could easily divide like we would in question 1, for example. So we have to distribute here. You only distribute into the brackets until after the brackets open, and then until they close. So the 2 gets distributed onto the n and the negative 3. Yes, Messenger. Yeah, but I still have to multiply this thing by 5 then, and that is a can of worms I don't want to open for 90% of you. But you are technically correct, but shh. So the negative 84 is going to stay there. I'm going to get 2n, and then 2 times negative 3 is minus 6. Now I have the 10 is going to get distributed in here. Positive 10, because you have to include the sign out front. Positive 10 times negative 3 is negative 30. So this is going to become 2n minus 6 minus 30, and then positive 10 times negative 5n is negative 50n. Positive times a negative is negative, 10 times 5 is 50, and the n comes along for the ride. And now I'm going to group our like terms. This guy here, this positive 2n, and this negative 50n, because you need to include the sign out front, are the like terms. 2 minus 50n is negative 48n. Then the negative 6 and the negative 36 are going to be grouped, and this is going to become minus 36, and the equals negative 84 nothing's happened to that yet. So now we keep going. I'm going to add 36 to both sides. It's negative over here, and these are being added and subtracted together. So to get rid of it on this side, I'm going to add 36 to both sides. Add 36 to this side. If you do that, negative 84 plus 36 should give you negative 48 equals negative 48n. Now I want to divide both sides. Because I'm multiplying negative 48 by the n, I'm going to divide by negative 48, divide by negative 48. Here it cancels, leaving me with 1n. I don't have to write the 1. But over here, negative 48 divided by negative 48, a negative divided by a negative is positive. 48 divided by 48 is 1. And because it's the only thing on the side, I have to actually write it down. There you go, Josh. Comments, questions, concerns? Anybody else? 1 to 16 odds. Is there anything anyone here would like me to go over? Which one? No? Okay. Then there was 11, 13, and 15. We had some answers down here that you could check while you were going. Okay. Did anyone attempt the optional and would like me to go over any of the optional? There were answers to the optional. Once, twice, sold. Okay. This was optional. Did anyone do and would like the answer to? Okay, nobody. Fair enough. These 2 were homework, so these answers I will give you. What were the headlines after a midget fortune teller escaped from jail? I know, calling someone a midget fortune teller, calling someone a midget is no longer politically correct. This was from 1989, so I do apologize if anyone was offended. But what do you call, or what were the headlines after a little person fortune teller escaped from jail? Did anyone get this? Anybody? No? It's a joke perhaps you've heard before. Nobody? Okay. Means we didn't do our homework. Shame. The headline should be small, medium, at large. A medium is another word for a fortune teller. If someone is a little person, that means they are small. And to be escaped from jail means you are at large. There's a small, medium, at large is the pun there. And then why do girls like guys who wear shirts with 8 buttons? Again, from 1989. But the puzzle can be done regardless. This was part of your homework. If you didn't do it, the answer was a fascinate, as in fasten 8. But it's a play on the words fascinate. It's funny. Okay, that's what you were looking for, solving all those things. If you did not get those done, if you did not even bother attempting them, the practice is the only way you guys are going to retain this stuff. So what you do at that point, I guess, is entirely up to you. Okay. Then there was the optional page, and if you guys didn't do the homework, I'm willing to bet you didn't do the optional. So flip ahead, lesson 5, fractions. Here we go. We love fractions, and now they're back. We are not going to turn them into decimals. We're going to deal with them as they are. And we sort of have already started to do this. Fractions can make these things more difficult, but there are ways to get rid of these fractions. And we have already kind of started to do this. The steps are here. Well, yeah, the steps are outlined here. And I'll go through them to show you how they apply. So what we want to do is when we've got these fractions we want to get rid of, what we want to do is we want to place brackets around every term. We want to multiply every term with the denominator of the fraction, and then simplify that fraction. Sometimes there will be there will be multiple different denominators. If there are 2 or more different numbers as denominators, there's 2 ways you can think about what's going to happen here. You can either find the lowest common multiple, which I'll abbreviate as the LCM. LCM stands, you know what, I'll write it out. Lowest common multiple, or the smallest number that both of the denominators go into, and then multiply every term by the LCM, simplify, and simplify the fraction. That word and should go here. Or another way to think about it is instead of multiplying it by the LCM, you can instead multiply, or multiply by each denominator. I'll show you what I mean. So these first 2 aren't actually that bad to deal with. We've done them before. I've got x over 4 equals 3, and I've got 19 equals x over 3. A fraction is just a way to write what mathematical operator? Fractions are just anybody. Yes, Hassan Joe. Division. So when we're trying to isolate for a variable, we always want to do the opposite operation to get rid of what's there, to get the variable by itself. So if a fraction is just division, to get rid of it, we're just going to multiply. So over here, if I've got x over 4 equals 3, I want to multiply both sides by what we're dividing by. Whatever I do to one side, I have to do to the other. The opposite of dividing by 4 is multiplying by 4. We do this so that On the left-hand side, dividing by and multiplying by the same thing cancels it out, undoes that operation. 4 divided by 4 is 1, leaving us with just x. And then 3 times 4 is 12. We've done those already. Those are questions I've already tasked you with doing. This next one is the same. If I've got 19 equals x over 3, the opposite of dividing by 3 is multiplying by 3. So it doesn't matter that it's on the right-hand side. We're still going to do the opposite to get rid of the thing that's attached to the x. The opposite of dividing by 3 is multiplying by 3. Whatever I do to one side, I have to do to the other side. On the right-hand side, they're going to cancel, leaving us with x. And because we all know our 19's times tables, it's a joke. I don't expect you to know your 19's times tables. 3 times 19 you can use a calculator for, or you can use your multiplication tables. 3 times 19 is, anybody? Josh, I see that hand. You bet. Okay. These are examples of questions with fractions that I've already asked you to do. Let's make it more interesting. Okay. So, I've got x over 2 equals 3 plus x. And I want to get my variables by themselves. Whenever you see fractions in these questions, I'll say like 98% of the time, the best first move is to get rid of those fractions. Do everyone a favor, get rid of the fractions. So, it doesn't matter that we've got x's on both sides, we're going to get rid of that fraction. If I've got x divided by 2, to get rid of that fraction means I need to do the opposite operation to get that thing out of there. The opposite of dividing by 2 is multiplying by 2. And whenever I do to one side of the equal sign, I have to do to the other side, the entire other side. So effectively what that's going to look like is I need to multiply the entire other, no, that looks like I'm squaring things. The entire other side needs to get multiplied by 2. I'll get rid of this. And so what's going to end up happening here is both of these terms are going to get multiplied by 2. On the left-hand side, these 2's are going to cancel, leaving us with just x. On this side, both of these terms get multiplied by 2. So 3 times 2 is 6, and positive x times 2 is positive 2x. Every term on the other side gets multiplied by the 2 that we use to get rid of this. And now this becomes a question that we can do relatively easily. I want to bring all my letters over to one side, and I want to get all the values over to the other side. Unfortunately, what that's going to mean here is if I've got x equals 6 plus 2x, to isolate the variable by doing the least amount of work, I am going to make the variable negative. I'm going to subtract 2x on both sides so that this value stays over here. I want to leave the 6 alone. 2x minus 2x is 0, and 6 plus 0 is 6. Now x minus 2x is, or 1x minus 2x is, negative x. But I don't want negative x equals 6. I just want to know what x is. So how do I get x by itself? So which one do you want to do, Hasenjo? Okay, because I've got a negative x here, I don't want a negative x, I want to make the thing positive. To make it positive, I'm going to multiply by negative 1. What I do to one side, I have to do to the other side. On the left, those two negatives are going to cancel, leaving us with positive x. And then 6 times negative 1 is negative 6. We can check. The same way we've been checking since day one. Let's do a quick check here. Hope you have space. We're going to check x over 2 equals 3 plus x. I'm going to go back to my original equation, and I'm going to plug negative 6 in there. So wherever there's an x. So x over 6 becomes negative 6 over 2. On the right-hand side, I'm going to have 3 plus negative 6. Now, what's negative 6 divided by 2? That's going to be negative 3. And then 3 minus 6 is also negative 3. Is negative 3 equal to negative 3? It's not a trick question. Yeah, it is. So if that's a true statement, that means this is a true statement. To get rid of the fraction, I multiplied everything on both sides by that denominator. Okay. Got a few more of these things. When you're dealing with fractions, there was 2 ways I explained what was going on here. Up here in the steps, if you take a look again, I said that for number 3, if there are 2 or more different numbers as a denominator, you can either find the lowest common multiple, multiply and simplify, or you multiply everything by each denominator. I'm going to demonstrate both of those methods. Whichever one you like better is the one you choose to use. So first, over here, I'm going to demonstrate what it looks like to multiply by the LCM. This one we're going to do LCM, or lowest common multiple. So let's take a look at the question. I've got x over 4 equals 5 over 3 minus 2. There are 2 fractions in there. We don't like fractions. Fractions make you guys uncomfortable for some reason, so let's get rid of them. I've got multiple denominators here. I've got a 4, I've got a 3. What is the lowest common multiple, or the smallest number that 4 and 3 both go into? Take them. It is 12. So the LCM in this case is 12. So what I'm going to do to get rid of these denominators is I'm going to multiply everything, every term. This whole term gets multiplied by 12. This whole term gets multiplied by 12. And this whole term gets multiplied by 12. Each piece. What I get when I do that, now remember, multiplying a whole number by a fraction, I take that whole number and I put it over 1. And then I multiply numerators and I multiply denominators. So 12 times x is going to be 12x. 1 times 4, that 4 is still down there. Interesting. Multiplying the 12 by the 5 over 3 means I'm going to multiply the 12 and the 5 is 60. And the 1 times the 3 is 3. Minus. Now the 2 times the 12 is going to be, yeah. So I get 12x over 4 equals 60 over 3 minus 24. Now when you multiply by the LCM, the next step is to simplify. So what we're going to do is we're going to look at each of these pieces, the 12 over 4 and the 60 over 3, and we're going to see if we can simplify that. What's 12 divided by 4? 3. So that's going to simplify to 3, and I have an x. Equals. What is 60 over 3? 20. Minus 24. Just like that, the fractions are gone, and now we can solve this thing. What is my next step here, if you take a look at that question? Yes, Hassan Joe. Collect the like terms. I have a 20 minus 24 on the right-hand side. 20 minus 24 is, thank you, Scarlett, that is negative 4. So I have a 3x equals negative 4. So to get x by itself, we're going to divide by 3 On the left-hand side, they cancel, and I'm going to get x equals negative 4/3. Might be actually it's not the first time, but we got fractions as answers now. Okay, questions about what I've just done here? Okay, going once, twice, thrice, sold. Okay, cool. So that's what it looks like to do the LCM. I'm going to do the next question the other way, my OR way. Instead of multiplying by the LCM, we're going to multiply by each denominator, and I'll show you how that plays out. So take a look at this guy down here. I've got x over 2 plus 5 over 3 equals 2. This looks very similar to the previous question. But instead of doing it the LCM, I'm going to multiply every term by every denominator. So if I've got a 2, I've got x divided by 2 plus 5 divided by 3 equals 2. I've got multiple denominators here. They are different. 2 and 3 are not the same number. So what I'm going to do is instead of multiplying by the LCM, in this case, the LCM would be 6. Instead of multiplying by the LCM, what I'm going to do is I'm going to write that every term, the x over 2, the 5 over 3, and the 2, is going to get multiplied by 2, and it's going to get multiplied by 3. I'm not multiplying by the LCM, I'm multiplying by each denominator. So here's how I'm going to write that. This is going to be times 2 times 3. This one's going to be times 2 times 3. And this one's going to be times 2 times 3. Now some of you might be sitting there and saying, that's exactly the same thing as multiplying by 6. Right, Hassan Joe? The difference here, Hassan Joe, is the way I've written this allows us to make a simplification without actually having to worry about multiplying fractions. So look at why I did what I've done here. This first term means I have, looking at it, I've got a 3 times a 2 times an x divided by 2. If I multiply by 2 anywhere and divide by 2, those can just cancel. Before I do any multiplying, the 2 in the denominator cancels with the 2 that I'm multiplying. In the next term, that 3 in the denominator is going to cancel with what? That 3 I've got up there. So now before I've even done any multiplying, those denominators have been dealt with. It's like writing it like this allows me to effectively pre-simplify my fractions. And for some of you, this will go a lot better. There's no denominator here, so there's nothing to cancel here. And as long as I make sure I do each term, we're good. So what's left over here? The 2's have canceled, and I'm left with 3 times x, which is just 3x. Plus, in this middle term, my 3's have canceled. I'm just left with 5 times 2, which is, I heard someone whisper 10. And that's going to equal 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. So instead of multiplying by the LCM, if you break it up like this, this allows you to pre-simplify, which can make your life a lot easier. Now this is relatively simple to solve. The first thing I'm going to do to isolate for this x is to get rid of what? The 10. I want to get rid of any term that doesn't contain a variable. So if I'm adding 10, the opposite of adding 10 is going to be subtracting 10. On the left-hand side, I'm left with 3x. On the right-hand side, 12 minus 10 is 2. And on my last step is to, if I have 3 times x, I want to isolate x. So we're going to divide both sides by 3. 3 divided by 3 is 1, leaving me with 1x equals 2/3, and you are allowed to leave that thing as a fraction. If you want, you can write that as 0.6 repeating. That's totally cool too. So there's two different ways that you can tackle dealing with these denominators. Figuring out the LCM and then multiplying by it, or forget thinking about the LCM, just multiply by each denominator. Hands up if you like the LCM method better. Okay, a few of you. Hands up if you prefer this method. Okay, cool. So I'm going to do this last guy here. This will be the last example that I do. Which method do you want to see again? Hands up if you want me to do the LCM again for this question down here. A couple of you. Hands up if you want to see this method. Hands up if I should do it both ways. Okay, let's do it. Fine, you know what? Let's do it both ways. What could it hurt, right? Here we go. So I'll do the LCM way first, and then I'll do it this way. Okay, so if we're gonna do it the LCM way, LCM, what's the lowest common multiple of those numbers in the denominator there? Josh, 6. The lowest common multiple of 2 and 3 is 6. So what I'm gonna do is I'm gonna multiply every term by 6. This guy by 6, this guy by 6, this guy by 6, and this guy by 6. Each term, this guy, this guy, this guy, and this guy, have to be multiplied by that LCM. What that's going to give us is 6x over 2 plus, when I multiply by a fraction, I multiply the numerators and the denominators. 6 is the same as 6 over 1. So that's going to become 30 over 3 equals 2 times 6 is 12 minus 6x over 2. And now I simplify. 6 over 2 is, I heard someone whisper 3. So 6 divided by 2 is 3 and x plus 30 divided by 3 is 10 equals 12 is just 12. That's lovely. Minus, and now I've got 6 over 2 again, which is 3x. So now what I want to do is I want to get all my variables on the same side of the equation. I've got a 3x plus 10, and I've got 12 minus 3x. So to get them all over, the easiest way to do this is to move them all which way? Left or right? Moving them left gets rid of this negative. So let's do it that way. To move it over, because this is 12 minus 3x, I'm going to add 3x to both sides. Negative 3x plus 3x is gone, leaving me with just equals 12 on the right-hand side. 3x plus 3x is 6x plus 10. And now I'm going to solve this thing. I'm going to take 10 away from both sides, leaving me with 6x equals 2. I'm going to divide by 6, x equals 2 over 6, which I can reduce to what? 1/3. I can divide by 2 on top and bottom. So x equals 1/3. That is using the lowest common multiple. I'm going to do the exact same question again. Sorry, questions about what I've just done. Anybody? Did I lose anybody anywhere? Is there anything you're wondering about? Any mistakes that I have made? Okay, then I'm going to do the exact same question one more time. X over 2 plus 5 over 3 equals 2 minus x over 2. And instead of multiplying everything by the LCM, I'm going to multiply everything by every denominator. So I need to make sure I do this to every term. I'm going to multiply every term by every denominator. So the first one's going to get multiplied by 2 and 3. The second one's getting multiplied by 2 and 3. The third one's getting multiplied by 2 and 3. And the last one's getting multiplied by 2 and 3. Zoom this in so it's easier for you guys to see what's going on here. It's happening to each term. Now, when we do this, it allows us the opportunity to pre-simplify. So what's going to cancel in this first term here? Yeah, someone whispered the 2 2s. Dividing and multiplying by 2 is going to cancel. That guy's gone and that guy's gone. In the second term, what's going to cancel? Yes, someone whispered the 3s. Nothing is going to cancel in this term because all I'm doing here is multiplying. In the last term, what's going to cancel? The 2s. So my first one, I'm just left with x times 3, which is just 3x. My second one, I'm left with 5 times 2, which is just positive 10, equals 2 times 2 is 4 times 3 is 12. And then a negative x times 3 is negative 3x. Effectively doing it this way just means I can skip this whole middle line right here. Takes us right to this line here. And now I'm going to solve this thing the exact same way. I'm going to add 3x to both sides, giving me 6x. Can you wait till my lesson's done? And then you can go 6x plus 10 equals 12. I'm going to subtract 10 on both sides, leaving me with 6x equals 2. I'm going to divide both sides by 6, leaving me x equals 2 over 6. And I can divide both of these by 2 again, and I get the same value I had before. Doing it this way really only just takes out that one line. But taking out that one line is not an insignificant savings. So 2 different ways to handle the exact same style of question. I don't particularly care which way you choose to do. You just need to pick a way, get comfortable with it, and then be able to show me all the steps for whatever method you've chosen. Questions, comments, concerns about what we've done here? Taria, give me 1 second. Let me assign you the homework and then you can go. Okay, here's what I want you to take a look at. Ooh, you know what? There's a whole second part to this too. Okay, I want you guys, we're going to break this lesson up into 2 chunks because we've only got 20 minutes left. I want you to look at the monomial, practice the monomial numerator. So this page, I want you to do, ooh, hold on. Yeah, let's do it this way. I want you to do odds on this page. Okay? So it says practice monomial numerator odds. Then I want you to flip ahead. We're going to skip the binomial in the numerator. We're going to save that to tomorrow because of the limited amount of time we have. Flip ahead to where it says lesson 5 homework. I would like you guys to do part 1 and part 2, both of these parts. I'm going to get you guys to do, let's say aces on both of them. Aces on both. So that's 4 out of those 8 questions there. So odds on that first chunk, flip ahead, do aces here. You've got about 20 minutes left. Daria, you can go. Okay. On your mark, get set, giver. We'll come back and look at binomials tomorrow. It'll be great.